0.02. And then the depth now is equal to 0.015 minus y. Okay. And then the centroid is equal to half 0.015 plus by y. Okay. So from here, this will be equal to 80 times 10 to the power minus 6 plus by 4.5 times 10 to the power minus 6 minus by 0.02 y squared. Okay, so this will be equal to 84.5 times 10 to the power minus 6 minus by 0.02 y squared. And then we can now calculate our shear xy of the web. So this will be equal to 80, or will be equal to, so I write down the formula. Right, question for all of you. We are looking at a different section now, right? Now we are looking at the top web section. What is the Vy we're going to use? Anyone?
Half of the original, so 90 kilonewtons.
No, what did I tell you?
It's
Vy is always a constant. Yes or no? Does that make sense? Yes or no? What did I remind you again? Right? Vy is always a what? A constant. I understand why you want to divide by 2, because there's a left and a what? And a right. You do the division not on the shear force. I repeat again, you have to apply rule number 1. Vy is going to be a what? Constant, regardless of the region that you're going to look at. Izz is also going to be a what?
Constant.
There you go. Okay. Izz is also a constant. Some of you like, oh no, but Eugene, you just draw the shear force, it split. Yes, it did split, but okay, you still write out as a constant. Later on, you'll compensate elsewhere. I'll tell you where. So Vy now is equal to 90 times 10 to the power 3, right? Over Izz is equal to 5 points. So both of these are constant. Okay, 8133 times 10 to the power minus 6. And then you find your Qz, which is 84.5 times 10 to the power minus 6 minus by 0.02 y squared, right? And then now your T, right, is equal to what? So if you look at our thickness, is 0.02. Yes or no? So that is the thickness that we have. We have 0.02, right? And then how many web you have? 1 and what? 2. So this is where you compensate. So this is for your left and what? Right. Remember, okay, what I'm telling you is this. Regardless of whatever region you look at, these terms over here, leave it constant. The rest of them are your what? Variable. If not, you get very confused. Confused in what sense? Did I consider it or did I not consider it yet? Okay, it's the yet. Okay. Any questions so far?
Sorry,
Yes.
for QZ, you did multiply by 2 for left and right, right? Like up in your calculation?
I did.
So does that mean you consider it in like just in your first moment of area calculation, but not in your thickness, that type of thing? Like,
no, this QZ is for the entire is for the entire shaded thing that I've done for you over here. It's everything.
oh, okay, got it, for the whole.
Yeah, because that's why the 2 is you have left and a right. Now this is for thick wall analysis. Later on, when we go to thin wall, things will change again. Okay, so this is for thick wall analysis. Right. So from here, we will come out with an expression. So this will be equal to 387 .0435 times 10 to the power of 9, 84.5 times 10 to the power minus 6, minus by 0.02 pi squared. So this will be equal to 32.705 times 10 to the power of 6 minus by 7.7409 times 10 to the power minus 9 pi squared. Okay, now listen, I understand that the quiz is going to start at 12, but don't worry, I give you guys up to what time? 3 o'clock, right? So let me finish this example, then go and do your quiz. Am I okay or no? Okay.
Yep.
Yeah, I will not be more than 10 minutes. Okay, I will be not more than 10 minutes. Right. So from here, we know that when y is equal to 0, right? Shear xy will be at its maximum and is equal to 32.705 times 10 to the power 6 Pascal. We know that now. So that's our max. Now the question comes with this. Okay, as I said, I'm teaching. Okay, you don't need to do the next step, but I'm teaching. I want you all to see something. Now, how do you know that this is correct? Anyone? How do we know that this expression is correct again? Anyone? I got no takers. How do we know that that
when
point?
tau xy equals 0, y should equal 0.0075.
No, you can't do that now. Okay, you cannot have that explanation now, because if we were to sketch, I'm going to sketch the profile out, right? So if this is your shear, this is your y, this is your flange, right? Because of the thickness change, the web, the stress will increase and then come back down here. This is how your profile look like. Okay, so your statement that you just made regarding half of it, that is not valid. You see why now? Yes or no?
Yeah.
Yeah. Okay. Good try though. Okay. So how do we know this is correct? Okay. So as I say, this is teaching. Okay. You don't need to do this. Okay. But sometimes the question might ask you to find the stress distribution at the bottom web. Okay, so now we're going to derive the bottom web. Okay, we're going to derive the bottom web. So now I want to know the bottom web. Okay, so that is our ZZ, and we want to look at our bottom web section. Okay, so bottom web section. Now our limits is 0, y, and 0.065 millimeters. Okay, because from here to here is 35, and from here to here it is 65. Okay, so remember what I told you? The analysis, you cannot cross the what? You cannot cross the datum. You cannot cross the centroid, right? So the only way to do this, if you're going to have a y variable, right? So we are going to have a y variable. So this is our y now, right? The area of interest is here, right? And then over here, This become your what? Your y bar. Okay, that becomes your what? Your y bar. Okay, so I do understand that the shear force is coming from here. I do understand that the shear force is coming from here. You tell me, Eugene, didn't you say that the shear force will distribute this way? Yes, I did. I did not say no. But now, based on the rule we apply, the analysis will start from where? This is your analysis direction. Okay, mathematically, that is your analysis direction. Okay, so from here, that's where things get a bit confusing. Okay, some of you, hey Eugene, the shear force is from the flange coming down. Why now you ignore it? Okay, so we have to obey the rules that the analysis will start from what? Y max. Okay, and it cannot cross the what? Centroid, right? And this is because the problem comes with the first moment of area. Okay, so now we have QZ is equal to AY bar, right? So the area, so twice is because of the left and right, right? The width is 0.02, and then this is 0.065 minus y. The centroid, the individual section centroid is equal to half 0.065 plus by y. Okay, we have the expression, right? So this over here is your left and right web. Okay, so from here, your QZ expression will be equal to 84.5 times 10 to the power minus 6 minus by 0.02 y squared. Okay, does this look familiar? Anyone? If you look at these two expressions over here, right? This we derived earlier, and this we arrive now. The first moment of area is the same, whether you take from the top or from the bottom of the centroid. Mathematically, it's very interesting for this case, right? The numbers, how we get there in terms of numbers, right? At the top, the numbers are not the same, okay, left and right. When you do this, right, the QZ from the bottom is shorter, okay? So this is one way to check, okay? This is one way to check whether your numbers are right or wrong by just doing the first moment of area. Then if you proceed further, so we are going to calculate now the shear XY. Okay, so I do apologize. This is shear XY. Okay, this is shear XY at the bottom. Okay, and then this is the shear XY. No, that's the top. What am I doing? What am I doing? And then this is shear XY at the web at the bottom. Okay, so this will be equal to the shear. Again, the Vy over Izz Qz multiplied by T. Right, like what I told you, it is constant. Okay, divide by same number 5.8133 times 10 to the power minus 6. Same thing, so this is 84.5 times 10 to the power minus 6 minus by 0.02 y squared. And then the thickness, again, you have to do the 0.02 for the individual one, and then you have to multiply by 2 for the left and right. And finally, this will be equal to 32.705 times 10 to the power 6 minus by 7.7409 times 10 to the power 9 y squared. Okay, so whether you take from the top, you take from the bottom, your answer will be the same. Okay, so I'm going to stop here now. Okay, any questions before you guys start your quizzes? Any questions? No? Okay, don't go away. I'm going to talk more about the quiz. Okay, so don't go away yet. Okay, I'm going to describe more about the quiz. Don't go away. Let's talk about the quiz first. Let's talk. Don't go away yet. Let me stop recording.